Photochemical smog is the focus of the entire chapter. If you understand smog really well, I can say you understand air pollution really well. So to review again, primary air pollutants are the stuff released directly into the air, and they interact with each other or other components of the air and form the secondary air pollutants. And the photochemical smog are actually the secondary air pollutants, which means there's some primary stuff have to be persisted there to give us a nice smog. And the smog is a mixture of pollutants. So these are the food we finally cooked and ready to serve. That is ozone, aldehydes, and the PAN. I do not require you to remember the PAN, but I do require you to remember the ground level ozone. The ozone resulted from the photochemical reaction. That's the products of the reaction involving the primary air pollutants here, which are nitrogen oxides, volatile organic compounds, the hydrocarbons, and I want to point out two very, very important things. Now I'm slowing down, okay? The two very important things, one is sunlight, the other is a warm temperature. And to review again, the ozone we talk here is a ground level ozone. We are not talking about the ozone in the stratosphere. That protects us from UV. I'm talking about the ground level ozone generated from the photochemical smog reaction. That is very harmful to the living things and especially to us humans. To review again, so our cooking material, we are cooking a very nice meal under the warm sunlight in a warm day. And our cooking material are nitrogen oxides and VOC hydrocarbons. And those nasty stuff come from the burning of the fuel in driving vehicles and industrial processes. And the industrial process, that's not limited to combustion, but mainly combustion. And the sunlight and the warm temperatures are two key factors playing in this reaction. And I do not require you to remember what the reaction looks like, but if you are curious and interested, you can take a look. And this is a vicious cycles over and over again. So the reaction is being cooked as long as we have warm temperature and we have decent sunshine. And this table looks very intimidating, but don't be intimidated. My main point here is those nasty ingredients are from automobiles and from industrial process. And the sun and the warm temperatures are very important. See, I emphasize this over and over again. So if in the test you still don't know, then I can tell you do not watch my videos. And the end products are PAN, aldehyde, and ozone. This is how the ground level ozone is generated. So when the ozone in the place it's supposed to be, it's really nice to us, right? Nice for us. And if it's in the wrong place, then it is our enemy. This serves as a case study to understand sunshine and the warm temperature. The brownish line is VOC. This dotted line is aldehyde. And this line, with the longer broken line, that is ozone. So these two are the end products of the smog. And let's see the cooking material VOC and nitrogen oxides are these two green lines over here. Now I want you to pay attention to the peak. What does a peak mean? The peak is the amount of pollution. You can see at night and before the sun rises, it's pretty flat. It's at the lowest point, right? Why it's begin to pick up? Because of the sun rises in the morning. And then because the sun is present during the day, this reaction will be cycled and being cooked on and on. And we see a peak of those nasty ingredients, the end products, the nice meal we cooked, show up around noontime because the temperature is highest. Probably the radiation, the sunshine is the strongest. And when we come to the evening, when the sun sets, okay, after the sunset, it could be still in a warm area, but you can see the lines start to go down because the sun is gone. The sunlight is gone. So that's why at nighttime and before in the early morning before the sun rises, you can see how the temperature and the sunshine play in these reactions. Sometimes we have especially very bad news, depending on the geographic in the local areas. And so I want to mention about thermal inversions that occur when warm air becomes sandwiched between two layers of cold air and acts like a lid on the valley. So when the warm air is sandwiched, it cannot move, right? It's supposed to rise up, but there's cold air sitting on the top, so it cannot go anywhere. And it is particularly bad. So the geographic areas could look like this, right? So the cold air sit on the top because this warm air is sealed by the mountains around this region. So it's capped with this lid and persists, in the atmosphere. And this is another scenario. It's the cold air slip down and the warm air cannot go off. And you can read the details, the 1, 2, 3, 4 here. And to save time, I'm not going to go through all these details. And also we have this landscape. There's one side, the cold air go from the underneath. Usually, if it go from top, it doesn't cause too much trouble. If it goes underneath, and then there's cold air sit on the top, still those warm air is trapped. So this is particularly bad because it will trap the air pollutants, and the air pollutants cannot go away. So the concentration will be greatly increased and persist for a long time in the area. And that causes very serious health problems. Like one example in our textbook, in 1953, the town in Pennsylvania, 20 people died. It's because of those cold air trapping the warm air close to the ground and trap those pollutants. That's why those people died. The acid deposition, as I mentioned before, no matter it's wet or dry, no matter it's snow or ice or rain or it's dry particles, all of them are called acid rain. And the acid rain has natural causes, and unfortunately with human activity, such as burning of coal and the use of internal combustion engine, we contribute a lot to the acid precipitation. And it is a worldwide problem because it's worldwide movement of air. And it looks like this. We have a nice sources of those nasty precursors, and they will carry on by the jet streams of the air, and it will precipitate in various forms, sometimes fog too, into the forest ecosystem, lake ecosystem, crops, river ecosystem, and urban area, and cause a lot of damage. And I showed the picture before. And also it goes through these vicious cycles, like the photochemical reactions. And the effects are very bad, killing of the trees. Okay, sterilize the lakes. When the pH change a little bit, a lot of species are no longer reproducing, and many of them died. A lake with a pH of 4.5 or lower are nearly sterile, doesn't support any life. I will stop here. So we have one.